Hello everyone, this is Ramakant Gupta. I have total 17.5 years experience in IT industry. I am currently working as a senior engineering manager, a technical architect and a full stack developer. So from today onwards, we are going to open a new series where we are going to discuss about Java interview related questions and answers. So today's agenda is about string, understanding what are the different ways we can create a string, what is the memory management for a string, and how we can view the memory footprint on the of the JVM using different tools. So virtual VM is one of the tool. We are going to see it. Okay, so let's go ahead and get started. Okay, so basically what we say about string, we understand string is a immutable, right? uh, what is mean by immutable? Immutable in the sense something once it's initialized cannot be changed later. So that is mean by immutable, right? So why JVM or Java has made a string as a immutable? Why Java has not made it as a mutable, a string, right? So there are different ways we can create a string in Java, and based on the way we create the string, it's considered as a mutable and it's considered as a immutable. So we are going to discuss, if we create a string in that way, it's considered as a immutable string. If you create the string in different way, it's considered as a mutable string. Okay, so when we create a string with when we create a string using either a new keyword string as a object and we use a new keyword, or we create a string as a literal. So this way of creating a string is called a string literal, and this way of creating a string is called a using a new keyword, right? So this, if you create a string via these two ways, it's a considered as a immutable string, in the sense once you initialize its a value, it cannot be changed, right? So ideally, if I say, if I have created string s2, string str2, hello Java, right? And if I try to give value str2 equal to something not working, let's give anything and not working properly, something. So what string should give me, what JVM should give me message if I try to compile this string or this program? If I say it's immutable, so ideally it should give me error, because once you have initialized the value over here, you are not allowed to change the value. Then what is, but here the JVM is running, or my Java program is properly running, it's not giving any error message, right? So what is mean by immutable? So let's understand what is the implication of this different types of object creation on the memory. Okay, so when we create object via this way, or we create object via this way, what is the memory implication on that, on these methods or this way on the JVM? Okay, so yeah, so we know JVM is broadly divided into two category. One is a stack memory and one is a heap memory, right? And under the heap memory there is another memory. Again, like there is a, we are going to get more detail into JVM architecture in some other video, but here we are just trying to understand high level how the object referred or how the object is created when we use a new keyword, or when we create a string using the string literal. Okay, so inside the heap memory there is a string pool, and this string pool is nothing but a hash table. So we know like what is hash table. Hash table is made up of key and value. Okay, key can be any data type and value is either a linked list or node. Okay, so let's go ahead. Okay, so when we see, when I create this string, let me just go first over here. When we create any string using this new keyword, so how the JVM creates this string into the virtual memory or JVM. Okay, so when I create the string, it's a reference. Its reference means this is a reference. This is a reference variable is created into the stack memory, but it's a value. Its value means it's a memory address goes into the heap area. So this is my heap memory. Under this heap memory, the this hello world will be created in my heap memory, and this will be referred by str1. Okay, now let's go to str2. When I create a string using a string literal, so how this memory will be handled by the JVM? So what JVM does, as it's a string literal, JVM does not create this object into the heap memory. Instead, what JVM does, it creates into the string pool. Now, as I've already told, what is a string pool? A string pool is nothing but a hash table which is based on key and value is nothing but it could be linked list or tree node. Okay, so here str2 is getting stored into the it's a reference variable is getting stored into the stack memory, but its a value is getting stored into the string pool. Okay, now let me come to another variable that is again in string literal, that is a str3. Okay, when I create object of str3, same way as it's a string literal, its a object reference will be created into the stack memory. But here what happened, when JVM goes and check whether with the same value, with whether same value already exists into the string pool. So instead of creating another entry into the string pool, what JVM does, it refers to the same value, right? So here what is happening, both string 2 and string 3 are referring to the same value into the string pool. Okay, so basically how it internally JVM works, how this hash table works, we know it has key and value. Okay, so whenever we try to store any value into the into the string into the hash table, what JVM does, it based on the value or based on the key value, it calculates what is a hash code, right? And using that hash code, it defines what is the index number in which it has to fit. So basically this string pool is nothing but a bucket. Bucket means we can say it's nothing but like it's a something like this. It's a row basically. It's a row of data. So like this is a string pool. It's a row of data. Row of data. It's a row of data, right? So each item is having value. It is having one key. This has index position 0 1 2 3 4, like this. The JVM has assigned each bucket a unique value, right? It is called a bucket number, right? Now what JVM does, whenever you try to add any value in, when JVM tries to add any value into the string pool, what JVM does, it creates a hash code, and based on the size of the string pool or the bucket size, it tries to calculate which position or which bucket number that value go into. Now question is like what hash code does. Hash code help us to calculate some value, and what this value means, like if for a particular string, if I try to calculate a hash code for any number of times, if you try to calculate the hash code for a particular string, it will return the same hash code. That is the concept of hash code. But what hash code says, it's possible that for two different string, same hash code can return, right? So let me take some other example. It may happen that str4, right? str4 can, which is having value hello all. Right? It's possible that JVM can calculate the same hash code for hello all also. So what will happen? Uh, so whatever the hash code has been calculated for str2, same hash code can be calculated for hello all also. So what will happen when JVM tries to insert when JVM will try to find out the index position, it may happen that same index position it may find, right? So what JVM will do, it will store the value as a linked list, right? So what is happening here? The collision is happening. Collision means already a particular data is residing into the bucket, but another data also came into picture, right? So here what is happening? Collision is happening, right? So to resolve that, what JVM does, it has the data as a linked list. So this data which already exists, the next data which comes into this linked list will be stored in the sequential. It will be pointing to each other like this. So based on this, yeah, let me just, okay, like this, it will be just a linked list will be created and it will be pointing to next data. Okay, so based on the JVM version or JDK version, either it could be linked list or it could be tree node. Okay, so this is clear, like how our object is getting stored and how it's being referenced into the JVM, or how it's being referenced into the string pool. Now when I say these two object str2 and str3 have hello Java as a value, and the JVM is referring to the same reference, right? How can we prove that? So let's go to our practical example. So here we are saying str2 is having hello Java, str3 is having again hello Java. So ideally, if they are referring to the same object, and if we try to check via equal symbol, it should return me true, because here what we are doing, we are not checking the value. Instead what we are doing, we are checking the reference of the object, right? So str2 str3 should return me the same reference object, and this output should give me the true. Okay, now let's coming to this first condition. Here str1 is referring to object which is into this heap memory, right? Even though str1 and str2 has the same value, but they are not referring to the same memory area or same memory location, right? So when I try to compare this object str1 and str2, they should not come as a true, they should be false. So when I try to run this program, I just run this program. If you see here the output, let me just run it again. str2 str3, okay, okay. See, if you see the output, str1 is equal to str1 equal to str2, this is coming as a false, because both are referring to the different memory address. And here str2 is equal to str3, because they are referring to the same string pool or same memory area, right? Okay, so now let me try to show you one more example. String str2 str4 equal to new string. If I try to create any string via new keyword, and let me try to give the same value, so what is our understanding? If I try to compare str1 and str4, will they have the they are the same object? Will it give the same will it give the same reference to each other? Okay, so let me try to compare it. So str1 is equal to str4. So I'm just trying to understand whether if I try to compare str1 equal to str4, whether it will return me the same whether it will return me true or false. Okay, so what happens when you try to create any object using new keyword? What it does, let me just here let me okay, instead of let me give str5 over here, better here str5. Okay, so what JVM does, it creates a reference object over here into the stack memory, that is a str5 will be created. But what JVM does, instead of referring to the same, because here also we have some hello world, right, which value exists, JVM does not refer to this value. What JVM does, it creates another memory area, that is a memory address hello world, sorry, hello Java, hello sorry, it's a hello world, and it refers to that, it refers to this. So here str1 and str5 are referring to the different memory area, so they are not same. So let me just see whether they are what is the output. Okay, see, we can see str1 is not equal to here typo, but actually it's a str5, they are not same. Okay, so this is clear, right, how the memory allocation is internally happening. Okay, now question is like, when should I use this string literal, or when should I use new keyword? Okay, so there is some scenario, what happen if you use a new string keyword, you are using lot of string new keyword. So what is happening over here, see, you use the new string keyword. Okay, so what is happening over here, what JVM is doing, JVM is creating is unnecessary, is occupying the heap space, right? It's creating the, for every object you create, it's trying to create a new memory area, or trying to allocate a new memory area for that object, right? So like this, if you have thousand hundreds of object using the new keyword, you are occupying that many space, right? So one solution to resolve that, what you can do, let me just give one example. String 6. So when you say string 6, okay, and you say interim, there is an interim method. So what this interim method does, instead of JVM creates into the heap memory, this, instead of JVM creates this this value into the heap memory, what JVM does, okay, it checks into the string pool whether the same value hello Java exists or not. If it exists, so what JVM does, let me go over here, string 6 str6, what JVM does, instead of creating the heap memory, it maps this to the string pool, it maps to this string pool. So this statement whether it's correct or not, let me see. So if it's mapped to the same string pool location or same string pool memory address, so ideally str2 should be equal to str6, even str3 should be equal to str6. So we can prove that. Let me just show over here. str2 is equal to str6. Let me just prove it. str2 is equal to str6. Similar way, str3 is equal to str6. str6. Okay, let me run it. my mistake. It's a hello Java. I have to write hello Java. It should be hello Java then only. Okay. So what we are expecting, string 2 and string 6 object should refer to the same memory area that is into the string pool, and they should be true. So you just check the output. They are coming as a true. Okay. This shows that when you try to create any object using new keyword, and if you give interim, so what JVM does, instead of creating into the heap memory, it checks into the string pool whether the same for the same value, if any date entry exists into the string pool. If it exists, so it simply point to that memory area. Okay, so this is clear, right? So why we use interim? We, instead of creating a new object into the heap memory, to avoid unnecessary burden onto the heap memory, we create into the string pool so that existing reference can be used. Okay, so this is the power of, this is the use of interim method. Okay, now let's coming to some of the important point which we should understand about the memory allocations. Okay, so there are some of the parameters which I want to show you guys. There is one parameter that is let me just show over here. Okay, so there is one parameter, print flags final. What this parameter does, it is used to list all the JVM parameters which is available for you. So for JVM or JDK7, there could be separate list of parameters. For JDK8, there could be separate list of parameter. Similar way for different JDK, there could be different list of parameters. So what we can use, we can attach this parameter to our JVM, and we can see what are the list of JVM parameters available for us. Okay, and to attach this parameter, what we do, -xx colon plus means we want to enable the feature. If you do minus, you want to disable that feature. So if I give this parameter print flags final, so what happens, let me just show you. -xx colon plus the feature I want to print flags final. So let's see what happens. I am attaching, this is my IntelliJ. Okay, and let me run. And currently I am using JDK 11. So I'll just show you. I am using the JDK 11. Okay, so to this JDK 11, what are the JVM parameters available in my system? All those parameters will be shown, all those parameters, right? Okay, okay, fine. Now coming to this point, let me just try to give you some more information. When the string pool is created, what JVM does, JVM creates there is one parameter, string table, print table statistics. So what, okay, string table size, okay, string table size. So whenever the JVM comes up, this is for JDK 11, it could be different for other versions. When the JVM comes up, by default JVM allocates a string pool of size that is a 65,537. This is a size JVM allocates for the string pool. But now coming, whether the memory, how the memory management of JVM is, how the memory management of string pool is done or not, how the memory management is done. Before Java 8, the string pool was allocated into the POM size. What that mean? Once the string pool size has been defined, it becomes constant. It remains constant for the entire life of the JVM. It means even though the reference has been nullified, the string pool remains as it is. The value remains as it is into the string pool. Right? It was never been garbage collected. But going from JVM 8, if JVM 8, are going from 8 11 9 10 11, right? I have observed that, or it's documented that JVM does the memory management of the string pool also. In the sense, JVM can adjust the size of the string pool. It does the garbage collection also. Previously, before to Java 8, it never did the garbage collection. The string pool remains till the life of the JVM. Okay. Now coming, what happens? What happens if you continuously give this string literal? If you continuously try to update the string, right, and if you continuously try to updating this value, so what JVM will do, since I told it's an immutable string, suppose that, let's take a simple example. You given some for loop. I have already, I think, created below some example. Okay, so this example, let's understand. In this example, what I'm doing, I'm creating one string literal. I'm doing some number of times loop, and I'm doing continuous updating of this value, right? So what will happen, since the value is different, so JVM will keep creating a new object into the string pool, right? So over the period, what may happen, that JVM size may get full. Either JVM size may get full if this object is not being garbage collected. If how they will not be garbage collected, if they are being referenced by some object, so obviously they will not be garbage collected. So okay, so for in this case, what we can do, either the object has to be garbage collected, right? But otherwise, like if what happened here, like you are trying to assign the same string little a different value. So due to the due to the string being immutable, a new value is getting inserted into the string pool. So to solve that problem, what we can do, we can create a string. There is another way to create a string object, that is a string builder. We can use the string builder. So what this string builder is there, string builder is a mutable version of the, or mutable way of creating a string. So what is a string builder? It's basically to create a mutable string. So what that mean, even though you keep updating the value of the string, it does not create a new memory address or new memory location. It keep updating the same value itself. So we understood the difference. One is the immutable, where we create the string using either new keyword or using a string literal. But using the mutable, we use the string builder, or there is a string buffer also. So why we use a string builder and why we use a string literal, right? String literal, if you want to create some string which you feel as a constant, right? Because it's a immutable, and you feel as a constant string you want to create, so you use a string literal, or use a new keyword for string creation. But if there is some for loop where you want to continuously update the value of the string, you want to update and you want to do some processing over here, right? So in that case, you use the string builder. So what JVM will do, when you use the string builder, it will create a mutable string. So instead of creating every time a new object or new reference into the memory, it keep updating the same memory address. Okay, so this we understood. Okay, so now coming to this point. Okay, so some JVM parameter I wanted to talk about, string table. Okay, so here I have enabled one parameter, that is a unlock diagnostic VM option. So if you enable this setting, it allows you to inspect your JVM memory. And what you want to inspect, I want to inspect a print string table statistics. So I told that in JVM the string pool is nothing but a is a table, is kind of tabular format, right? So that table information, the string pool information I want to know, so you can use this print table statistics. This variable you can enable, or this flag you can enable. And here, in case you want to limit the size of the string pool, so you can give some value. Suppose that I want to give only 20, right? So I want to limit my string pool size as a 20. Okay, now let's imagine a scenario. If you limit the size of string pool as a 20, but you are creating thousands of string literal. If you are creating a thousands of string literal, so what will happen? Since we have the same size 20 only, and you are going to create a thousands of string literal, so what JVM will do, uh, JVM will create a thousand bucket, but based on the there is a collision may happen, right? So multiple values, multiple string literal can have the same value, and JVM can store multiple string literal value into the same bucket value, right? Okay, so this is good. So this parameter is sometimes used for performance analysis, right? And now let me just show you. Let me just okay, open this and run it. Okay, it's giving error. It should be some range they have defined. Let me give you this range 2000. Okay, now let me run it again. So Java, basically Java JDK provides lot of under bean, it provides a lot of utility related to monitoring the JVM, related to monitoring the Java processes, right? So there is one utility, that is JPS, Java processes. It lists out only the Java processes. So if I hit enter, it lists me all the Java process which is running on my machine. So there is a 35305. This is the name of my Java process, and this is the process ID. Using this process ID also I can print the string pool details. So there is one more command, jcmd, and we can give the Java process ID, that is a 30524. Okay, process ID vm.string table. If we give this, it will give me all the information about my string table. Okay, so here I showed that here I have given the string pool size is 2000. String pool size is a 2000, but here I am seeing it's coming the number of buckets. Number of buckets is nothing but the basically nothing but a size of the string pool, right? But there I given 2000, but here it's a 8000 something is coming. As I told, right now, the JVM, based on the JVM, it's basically managed by JVM. It can manage as per the memory. It can manage. It can shrink automatically the size of string pool, or it can expand the size of the string pool also. Okay, so it has increased the size from 2000 to 8192. Okay, now how many entries, how many literal entries are there? Almost 20,000 entries are there. Okay, some are being, some see here, but here I try to store lot of literals, right? Almost 1 lakh literals I try to store, but here is showing just 10 almost 20,000 entries. Why? Because I told, right, string pool is now being garbage collected also, so JVM might have garbage collected. Okay, now coming to this point, this is very important point. There is a maximum bucket size. What is happening? There is a lot of collision is happening. Since our string bucket size is, since our string pool bucket size is very low, so what is happening, when JVM tries to calculate for every new string literal value, when JVM try to calculate the hash code, it may find the same index position, and it try to add into the same index position where the already some value is residing. So because of that, there is a collision is happening. So this shows that for a particular bucket, maximum how much collision has occurred, in the sense in a particular bucket how many values, how many number of values has been stored for. So it may happen like for index position 0, there may be 10 literal values are being stored. Again, for index position 2, there may be suppose that 5 collision has occurred, so 5 values got stored. Okay, so so what we use basically, if you see the lot of collision happen, in the sense what happen when you try to fetch the value from the JVM, what JVM has to do, again based on your key, it tries to find out the index position, and again it when it reaches to that index position, since there's it's a collision occurred, so data will be stored one after another in the linked list. So what JVM has to do, sorry, what JVM has to do, it has to pass through the index, it has to pass through the linked list and give you the value, right? So this reduces the performance of the JVM. So using this, understanding this parameter, then we adjust the value of this string table statics. So let me just increase this value. Suppose I increase to 2 lakh. Let me see how JVM behave now. Let me list out the process ID. Okay, the process ID is 32, sorry, this is the process ID 31712. 31712. Okay, you see over here, right? The number of bucket is now 2 lakh, more than 2 lakh. Right now, if you see the number of maximum number of collision, how it occurred. Sorry, maximum number of collision has occurred 3. Right. So previously it was 10, but now it is reduced to 3. In the sense the collision is less because we have increased the number of size of the bucket, number of in the quantity of bucket we have increased, right? In the sense number of rows has been increased for the string pool. So each, while calculating the value for the string, while calculating the index position for the string, it's there is no collision is happening, or very limited collision is happening, right? So this way we try to improve the performance of the JVM by adjusting this parameter which I suggested. Okay. This I was talking about. Okay. Okay, this I discussed dynamic resizing. JVM 11 has dynamic resizing of string table. Okay, string builder and string buffer is used for creating the mutable string. Okay, that's it about this video. If you like this video, please do like, subscribe and share this video. Thank you all for joining.